Hi student, welcome back again. So today we are going to start with chemical bonding and molecular orbital theories. We are going to solve numericals and MCQs based on it. Some MCQs which will be in the form of numericals, some are direct. So let us see some important question with respect to this topic. Let's begin with it. Okay students, let's start with the first question itself. The question is, among the following, the maximum covalent character is shown by the compound FeCl2, SnCl2, AlCl3 or MgCl2. Now we all know that polarizing power depends on two factors: the ionic size, radii, and secondly the charge on the cation. You see here the anion, that is Cl minus, is common for all. Now here Fe is in the form of Fe2 plus, SnCl2 mein Sn is in the form of Sn2 plus, aluminium is Al3 plus, and Mg is 2 plus. So what's your observation here? Aluminium has maximum charge. As a result, size is very small. So polarizing power is directly proportional to the maximum charge. So you see, maximum charge is shown by aluminium, which has a very small size. So polarizing power is more for this aluminium. Therefore, maximum covalent character will be shown by aluminium chloride. Okay? Largest charge means small size. Small size of the cation, more is the polarizing power. So don't forget, polarizing power is directly proportional to the charge, which is nothing else but inversely proportional to size of the ion. Okay? Chalo, let's go to the next question now. A compound contains X, Y, Z atoms. The oxidation state of X, Y, Z are +2, +2, -2 respectively. The possible formula of the compound is, very simple question, very simple. Now in this case, the valencies of X, Y, Z are given as +2, +2 and -2. Looking at this, you can straight away get the answer. So the answer for this question will be X, Y, Z 2. So the possible formula for the compound X, Y, Z is X, Y, Z 2. Very simple. So the answer for this question is A. The answer for this question is A. Okay, let's see question number 3 for this topic. A very interesting question. The correct stability order of the following resonance structure is. Now out of these 4 structures, which is the most stable one? Stable. So how will you go about with the most stable one? So let's see which is the most stable resonance structure. See, for resonance structure, what you have to see, the first point is covalent bond. The structure which contains more covalent bond will be highly stable. in case of resonance. So if you see the structure 1, 2, 3 and 4, you find structure 1 and structure 2, or sorry 3, structure 3, 1 and 3 have maximum covalent bonds. 1 and 3 both have maximum covalent bond as compared to structure 2 and 4, maximum covalent bond. So maximum covalent bond is observed in 1 and 3. So they are more stable than 2 and 4. Now among these two, which is more stable? Because both of them have the same number of covalent bond. In that case, you check the charge. See the charge now. You notice that here nitrogen has negative charge, whereas here in the third structure you observe nitrogen has a positive charge. Now the rule says if negative charge is present on more electronegative element, then it will be more stable. So nitrogen is highly electronegative. So if it has a negative charge on it, it becomes more stable. Whereas here, being highly electronegative, it is having positive charge. So stability is less. So when you compare 1 and 3, 1 will be more stable than third. Now second and fourth, out of this, they also have the same number of covalent bond between them. The number of covalent bond is same. But what is your observation? Here nitrogen, which is more electronegative, carries negative charge, and here it carries positive charge. So definitely second will be more stable than the fourth. So the order will be 1, 3, 2 and 4. Now look at the option. So option B is the correct answer for this question. Okay student, we come to one more question. Now this is very simple one. It says the number of sigma and pi bonds in peroxo disulfuric acid are respectively between two atoms. The first bond formed is always sigma. Now for this question, you should be aware of the structure of peroxo disulfuric acid. What is the structure of peroxo disulfuric acid? HO sulfur with double bond O, sulfur, double bond O, OH. Now look at this. This is the structure of peroxo disulfuric acid. Now let us count the number of sigma bond. What did I say? There can be only one single sigma bond between two atoms. So between two atoms, there can be the first bond is always sigma, and that is to be only one bond, which is sigma. Now this is sigma bond. Sigma we represent it by this symbol, 1 sigma, 2 sigma, then out of this 2 bond, 1 is sigma, 3 sigma, 4 sigma, 5, 6, 7. Now out of this 8, 9, 10, 11. So the total number of sigma bond is 11. How many pi bond? 1, 2, 3 and 4. So pi bond is 4. This is the symbol for pi bond. So your answer for this question is 11 sigma and 4 pi. So the answer will be B, which is the correct answer for it. Okay student, let's see a very interesting question, and that is the bond angle is smallest in H2O, H2S, beryllium chloride or nitrous oxide. Which is the smallest angle among this? So let us see the solution part of it. Water has a bent structure H2O with two lone pairs. The angle of water is 104.5. This angle is influenced by two factors: the electronegativity of the central atom along with the lone pair is that which affects the angle, bond angle. Hydrogen sulfide also is bent structure, but the angle here is 92.2 degree. Now why the angle is less? Because the electronegativity of sulfur is less than that of oxygen. It is less than that of oxygen. What about beryllium chloride? Beryllium chloride, BeCl2. This angle is 180. 180. Observe this. Observe this. Nitrous oxide. Nitrous oxide. These two structures are resonating with each other. What is your observation? This also has an angle of 180. So now observing the structures, what conclusion you can draw from here? The smallest bond angle they are asking for. So the smallest bond angle will be for hydrogen sulfide. It should be for B, the answer for it. So, student, let's see one more question, and that is the percentage of p character in the orbitals forming pp bonds in P4S. Now P4, phosphorus, has this structure P4. Now if you take this phosphorus, has one lone pair of electrons. Phosphorus, atomic number 15, 5 electrons in its outermost shell, 3 are involved, one lone pair you observe. They undergo sp3 hybridization. So it undergoes sp3 hybridization. Now since it undergoes sp3 hybridization, the p character will be 75%. 75%, and the S character for sp3 is 25%. So the answer for this question will be D, 75%. Okay student, now a very interesting question. Which species has the maximum number of lone pair of electrons on the central atom you want? For this, you should be knowing the structure of it and the hybridization part of it. So, let's see the solution part. First, option A, Cl is the central atom. This is O here. This is oxygen. This is O with negative charge, and there is only one lone pair. One lone pair is present on Cl. We all know the outermost shell of chlorine should have 7 electrons according to Lewis structure. So 2, 3, 4, 5, 6 and 7. So it will have only one lone pair. Coming to next, xenon should have 8 electrons. Out of 8, 1 electron it is sharing with fluorine. So 4 electrons of xenon is used up. Left out is 4 more. So that means there are 2 lone pairs. 2 lone pairs. 2 lone pairs. It undergoes sp3d2 hybridization, whereas this is sp3 hybridization. Now SF4, sulfur has 6 electrons in its outermost shell. So observe it. It has 4 hyd fluorine, 1, 2, 3 and 4 fluorine. Now this is the lone pair present here on sulfur. So this is sp3d hybridization. The fourth D is IF3 minus 1. I am drawing it here. It is I with I, and it has 3 lone pairs. 1 lone pair, 2 lone pairs and 3rd lone pair. Now how did I come to know there are 3 lone pairs? See, I has 7 electrons in its outermost shell. Okay. Now when you start drawing the Lewis structure, you will realize the total number of electrons involved. So from that I got 3 lone pairs. Lone pairs on the central atom I. So your answer for this question is, which one has the maximum number of lone pair? Is I3 minus 1. So the answer is I3, which is also sp3 hybridized. Okay. So your answer for question number 7 is D, and that is this. Okay. A very interesting question now, and that is the species having bond order different from that of CO is. Now how do you calculate bond order? How do you calculate bond order? Bond order is equal to number of bonding electrons minus anti-bonding electrons divided by 2 is the formula for taking out bond order. So let us first calculate for CO. What should be the bond order for CO? And then we'll calculate for others. So CO, total number of electrons, carbon is 6 and oxygen is 8. 6 plus 8, 14. 14 electrons. So this can be written as sigma 1s. The molecular electronic configuration can be written as sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2, then pi 2px2 equal to pi 2py2. So total number of electron used up 2 plus 2 plus 2 plus 2 plus 2 plus 2. So total makes up 12, and sigma 2pz2, sigma 2pz2. Now the bond order will be, first take out for bonding without star 2 plus 2, 4, 5, 6, 7, 8, 9, 10. So the total number of electron bonding is 10 and anti-bonding is 2 plus 2, 4, 4. Only 4. So divided by 2. So 10 minus 4 is 6 divided by 2. So bond order for CO, which has total electron 14, is 3. Now let us take the first one. NO minus 1. So total number of electron in this will be 7 of nitrogen and 8 of oxygen. So 7 plus 8 makes up 15 and minus 1. So it becomes 16 electrons. For 16, when you write the configuration, it will be sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2, then sigma 2pz2, sigma 2pz2, then pi 2px2 is equal to pi 2py2, then it is pi star 2px, which should be equal to pi star 2py. Let's see the total number of electron now. 2 plus 2, 4, 6, 8, 10, 12, 14, 15, 16. So now the bond order for this will be 2, first bonding 2 plus 2, 4, 4 and 2, 6, 7, 8, 9, 10. So 10 electron is for bonding. Now anti-bonding 2 plus 2, 4, 5 and 6 divided by 2. So 4 divided by 2 is 2. So NO has a bond order of 2. What about CN? Let's see. CN minus 1. CN minus 1. Carbon has 6 electron, nitrogen 7. So 6 plus 7, 13, and 1 minus 1 is 1 more electron. So total 14. So it also has 14 electrons. So bond order for this will be similar to CO, which will be 3. What about N2? N2, nitrogen 7 plus 7, again 14 electron. So its bond order again will be 3 only. So look at all of them and tell me which one has different bond order. Answer is NO minus 1. So the answer for this question is A. Okay student, let's see one more very interesting question which is based on paramagnetic compound. You know there are two types of compound. One is diamagnetic, another is paramagnetic. Now what do you mean by diamagnetic compound? The compound which have all the electrons paired. There should be no unpaired electrons. Then it is called diamagnetic. And when we talk about paramagnetic, it should have unpaired electrons. So they are asking you, among the following, the paramagnetic compound is. Okay. So let us do one thing. Take out this metal from here. So when I remove, if I remove K from here, it forms O2 minus 1. If I remove this potassium from here, which carries one positive charge, O2 will get one negative charge. Now calculate the total number of electrons in O2. 6 plus 6, 12. Sorry, oxygen we are considering, so 8. 8 plus 8, 16, plus 1 electron added. So total electrons will be 17. So O plus O and then 1 electron added. So it is 8 plus 8 and 1 electron added. So 17 electrons. So when we write the electronic configuration for it, sigma 1s 2 electron, sigma star 1s 2 electron, sigma 2s 2 electron, sigma star 2p, sigma star 2s 2 electron, then sigma 2pz 2 electrons, then we have pi 2px 2 electron equal to pi 2py 2 electrons, and pi star 2px 2 electron is equal to pi star 2py 1 electron. Now count the total number of electron. 2 plus 2 4, 6, 8, 10, 12, 14, 16, 17. Now what's your observation? There is one unpaired electron here. So that means this compound is paramagnetic in nature. Similarly, you can check it out for others. In that case, they all will be paired. So your answer for this question is D. Now this is a new question, student, which says which of the following compound would have the highest boiling point? Now whenever a question comes on it with respect to boiling point, the major factor which governs the boiling point is hydrogen bonding. What you have to see is whether the given compound has hydrogen bonding or not. Okay, so the main reason for boiling point is hydrogen bonding. If they have a hydrogen bonding, boiling point will increase. Now let us see which compound can have a hydrogen bonding. You know what is hydrogen bonding now? When hydrogen is connected to a highly electronegative element such as oxygen, fluorine, nitrogen, etc. That's called hydrogen bonding when it is connected to. Now if you look at these all four options very carefully, you understand there are two compounds which can go for hydrogen bonding. Which are they? One is methylamine. This is methylamine. And the other compound which can undergo hydrogen bonding is methyl alcohol. Now both can undergo hydrogen bonding. So the question is which will have the highest? Now the question is out of these two, which will have the highest boiling point? Others will not go for hydrogen bonding. So out of these two, which one will have the highest boiling point? Now that depends on the polarity, or you can say in a very simple language, it depends on the electronegativity. If you see very carefully, the electronegativity of oxygen on the Pauling scale is 3.5 and that of nitrogen is 3. The one which is more polar is oxygen. So the hydrogen bonding of alcohol will be more compared to that of, more stronger compared to that of amine. So your answer for this question will be methyl alcohol, that is C. Okay, so with that we end this topic, questions which are important from this topic. Now we'll cater to a new topic. Till then, see you all, be happy, be safe.